Let's take a look at naming polyatomic and multivalent ions. First, polyatomic. Poly means many, so many atom ions. So a polyatomic ion is an ion that contains more than one atom, but it behaves just like every ion. The polyatomic ions can be found on the ion chart. Remember, these are binary compounds. So on our periodic table of the ions, we've got our ion chart right here. These are polyatomic ions. Cyanide, CN1 negative. It's kind of hard to see that CN1 negative, but there it is. There are only 3 polyatomic cations. Cation meaning positive. The ammonium ion, NH4, 1+, that's in the chart. The mercurious ion, which is Hg2, 2+, and the hydronium ion, which is H3O, 1+. We won't be doing anything with these two, but ammonia will show up. For anions with cations, so anions means negative, anion, negative, anode, it's a negative pole in a negative place in a battery. Polyatomic ions with many atoms containing oxygen are called oxyanions. Their names end with ate or ite. The one with more oxygen in it is called ate. So we've got NO3, 1 negative, and NO2, 1 negative. Nitrate has more oxygen in it. Nitrite has less oxygen in it. All right, so let's look here at how to create the formulas and the names. So our first positive ion, we've got Na, 1+, and SO4, 2 negative. That means we need 2 NAs for every SO4. So it's going to be Na2, SO4. And Na is sodium. And SO4 is sulfate. It has the more oxygens, more than sulfite. So this will be sodium, sulfate. All right, the next one. BeNO3, 1 negative. Be is a 2 positive. So this means we need 2 NO3s for every Be. So we're going to write our beryllium here. Now we have to put our NO3 in the brackets here because we need 2 NO3s. So this 2 applies to the N and this 2 applies to the O3s. So in this molecule, or in this formula unit, there's 1 Be atom, 2 nitrogen atoms, and 6 oxygen atoms, 3 times 2. And this will be beryllium. And then we look up our NO3. NO3 is right here. It has the more oxygens. It's nitrate. So this will be beryllium nitrate. Now we have NH4, which is a 1+, and we have O, which is a 2-. So we need 2 of these guys to balance them out. So we put our NH4 in brackets, and we need 2 ammoniums for every 1 oxygen. So this will be ammonium, ammonia, oxide. Sorry, ammonium oxide. Ammonium oxide. This alone is just ammonia, but when we put it together, we call it ammonium. No, ammonia is NH3. This is ammonium, NH4. Ammonia is NH3. Now, in this formula unit, there's 2 N's, because the 2 applies to the N, and there's 8 H's. Ammonium oxide. All right, last one. Ca, calcium, and NO2. Well, this was nitrate up here, so this will be nitrite because it has less oxygens. So calcium has a 2 plus charge. So to balance the charges, we're going to need 2 nitrites. So we're going to get Ca, put the NO2 in brackets, and 2 of them. And we're going to get calcium nitrite. Okay, so that's how you name polyatomic ions. Now let's take a look at multiple cationic charge or multivalent ions. So simple cations have only one possible charge, group 1 and 2. Aluminum 3 plus, zinc, cadmium, and silver. So group 1 of 2 is like here and here. These guys can only take on one possible charge. Group 3 here can only take on one possible charge. It's in this transition metal here where things get confusing. But these few can only take on one charge as well. So it's these transition metals which can take on many different charges. Iron can have a plus 3 charge, a plus 2 charge, or it can even have a plus 1 charge. Iron can take on a lot of different charges. This chart shows the most common ones. It shows the most common 2 with the more common one on top. So iron 3 is more common than iron 2. But there could also be iron 1. All other cations are capable of forming ions with more than one possible charge. Mn is manganese, plus 2, plus 3, plus 4, plus 7. When you name a compound with a cation that can have multiple charges, like Fe3+, you must include the charge of the ion in the name of the compound. In this case, FeCl3 is iron 3 chloride. Compare this to FeCl2, which would be iron 2 chloride. Right? Because we have 2 -1 charges, so iron has to be a plus 2 charge. That indicates that it's a plus 2 charge. This is called the Stock system, named after Alfred Stock. The charge of the ion is given in the name, written using Roman numerals. 3, 2, IV for 4. All right, so let's take a look here at some examples. We're going to start off with copper 1 nitride. So our metal is copper, and it's got a 1 plus charge on it because it's 1. Nitride is an N, and it has a 3 minus charge on it. So to write our formula, this has to be Cu3N, copper 1 nitride. Now we have a Cu and an O. Well, we know that O has a 2 negative charge on it according to our periodic table of the ions. So because they are just one of each, our copper has to have a 2 plus charge on it. So this is going to be copper 2 oxide. Okay, now we have a dumb one. Well, we have the classical nomenclature here. Ferrous chloride, ferrous being iron. Ferrous classical nomenclature says add OUS for cation with a lower charge and adds ic for cation with a higher charge. So ferrous is Fe2+, and ferric is Fe3+. We don't use these. So we would name this, we would call this iron 2 chloride. Now, what does iron 2 chloride looks like? Well, it would have an Fe with a 2 plus. It would have a chloride with a 1 minus. So our chemical formula for this would have to be FeCl2. 2 chlorines to get the charge of chlorine up to -2. So we don't use ferrous chloride anymore. That's the old nomenclature. We call it iron 2. All right. So the next one is FeS. Well, we've got an Fe, and we have an S. And our S has a 2 minus charge on it. So because there's one Fe and one S right here, there's one iron atom, one sulfur atom, the iron must also have a 2 plus charge so that the charges balance out. We would call this iron 2 sulfide. Okay, so that's how you name multivalent ions. Now, classical nomenclature, we looked at it a little bit. OUS is the cation with lower charge. IC is the cation with higher charge. Ferrous means it's Fe plus 2, ferric plus 3. So, for instance, cobaltus with the plus 2, cobaltic with the plus 3. These aren't used anymore. We don't need to know about them. Do not use the classical system to name compounds. It just might show up sometime in a textbook, so you should know that there is another way to name these things that's not used anymore. All right, so plumbic nitrate, ic, meaning the higher of lead. So lead, the higher one is right here. It's 2 plus. I would call this plumbus nitrate, to be honest. We're going to cancel that guy. So all you need to know about the classical nomenclature is that OUS means charge with lower, IC means charge with higher. We use the, what's the guy's name again? Alfred Stock system, where we put the charge of the cation in parentheses. Iron 2 sulfide. Iron has a plus 2 charge. Right, that should be all that you need to know about naming polyatomic and multivalent ions.